plug and jump. So this is 9.8 times 100 times the sine of 30 degrees plus 0.7 times the cosine of 30 degrees over the cosine of 30 degrees minus 0.7 times the sine of 30 degrees which is 29.85. Wait for confirmation.
I got 45.84.
Okay, 45.4.
84. 45.8.
45.84.
Yes, yes.
Okay. We got two people with the same answer. It's encouraging. Do we have a third person or someone come up with something different? 29.85. Apparently I trusted the previous class too much.
I wonder if that's the
Gary?
I wonder if that's the radian one. Nope, radian is not real answer. Go.
30 radians, they should be able to decide 30 radians.
Fucking sim.
Just go around the circle for you guys.
Well, I put in radian one.
Sick and tired of that.
Oh, but that, you potentially end up with a negative under the radical.
Yeah. That's what it is.
All right, units?
Second.
And it's about 100 miles an hour. Yay friction.
And we went from.
Where'd that come from? So you have F cosine, I see you got FS max up top above your head.
That's the static friction max. So
Yeah.
which is.
And you got USY, is what changed.
USY. If you flash back a couple lessons ago, kinetic friction is equal to this coefficient of kinetic friction times the normal force. Static friction is less than or equal to the static coefficient times the normal force.
Okay.
And so the static friction again will match will match the applied force until you hit that breaking point, and at which point it suddenly starts to slide. Because I'm looking for the maximum speed where it won't slide, I'm at that breaking point.
Okay, makes sense.
What are we looking for the minimum?
The minimum speed where it won't slide, okay, we can do that. Any other questions on this before we flip around to finding the minimum speed?
The minimum speed for where it'll stay.
So it will not slide. All right.
So we're saying now, like before when there wasn't any friction, there's only one speed you could go where you wouldn't slide? But now that there is friction, there's a range?
Yes.
Okay.
Which, I mean, if you think about real life, whenever you've gone around a curve, you don't have to hit some perfect speed. You do have a range there.
Be real nightmare driving if that's the
Yeah,
case.
true.
I'm just thinking.
All right, so if we're now doing minimum speed, If we're doing the minimum speed, then what changes? Friction is now, if we're at a minimum speed, we're going below that ideal, which means that we're going to be driving below that 23 meters per second. And so friction is now flipping directions. And so friction is now in the opposite direction of what we had before. Let's see if I can come up with over red. Which means that this is now negative and that is now positive.
Oh.
Negative, positive, negative, positive, negative, positive. Let's make sure I didn't lose something here because the friction is now going up, so yeah, so that works. That works, okay. And so minus, plus, minus, plus.
That. Put that in there, right?
You end up with a.
You gave me an unreal answer.
I got it here.
You were like.
Ah.
If you do like I do, it's just really clear the random factor, because it's.
44.71.
No, I'm not buying that.
You did it.
Because we already know that going at 23 point.
Okay, no.
Yeah, cause you got
Whatever.
45
I
now.
don't know.
Oh, it's not a real answer because it won't slide down. Tires have enough grip for that, so you were in agreement.
Yeah. All right. So
I was about to say, I hope your tires can hold on to the 1 3.
so because we do have a negative under the radical, it is indicating the fact that it will not slide down. The car could actually just sit there on the slope and it's not going to slide down. So the minimum speed would be negative.
Don't need that myself like that.
Oh, sorry.
There is another variation of this problem where I tell you the speed the car is going and then ask you, and with the quote, the static friction, and then figure out what's the maximum minimum angle. It's basically, you're going through the exact same process, the only difference is the math. Now theta is the unknown instead of, theta and y are the unknowns. Once you get it down to here, you have a single unknown, and it's just math. And that's another situation where if you end up with a theta that's unrealistic, so if you end up with a angle of, say, -5 degrees, that means that's not gonna slide at all in one direction, or if you end up with an angle of more than 90 degrees, that means that thing's sliding no matter what.
You straight up.
Say it again?
Instead of straight up like this, so it's not gonna stay.
Yeah, that would be like
The
a
car would
infinite speed.
stick
Yeah.
right there.
Oh, shit. Spider car.
Well, they say that some cars now are designed with so much downforce at a certain speed that it can drive
Oh.
on its roof. But the engine won't run like that because fluids.
Are you saying stop? Sitting on it.
Yeah, that there is the downward pressure of air is holding it to the track.
Yeah, but you have to go 190, yeah, 190 plus miles an hour upside down.
Kinda like if you watch,
I think my science did do that.
if you watch motocross, when they take the berm, be way up here, and they'll hit the thing directly at 90-degree angle, sideways, it's usually what he's just talking about.
Oh, okay.
Yeah.
Well, if someone could run the speed of sound, you could run a loop the size of the Burj Khalifa or bigger. That's pretty good.
At some point, you do have to take air resistance into account, which we are ignoring.
You slap a chicken hard enough, you can cook it.
If enough kinetic energy turn into thermal energy or something like that.
No, you just make it more tender.
If you slap the chicken hard enough, you can cook it.
I guess Mythbusters did, or one of those did, that was if you could shoot a chicken through a piece of, through a board.
Yeah. Through a windshield, airplane windshield.
Oh, yeah.
Yeah.
Can airliners withstand
Lethality of
chicken?
bird strikes, confirmed.
They tried with
Yeah, but
frozen
it wasn't,
chickens.
it's not with the windshield, because the
All right,
rain.
at this point, we have covered the material for the next test, which I want to do before spring break.
So spring break only 3 days? Is that what I'm
Spring
getting?
break is Tuesday through Thursday. The Brain Trust decided that made sense, and so that's what we're looking with. Even though it does not affect us, because we're not having class that week, there are classes Monday and Wednesday, Monday and Friday of that week.
That's 3 weeks from now, right?
That's stupid.
Yeah, or 2.5 weeks.
It's because we now have 15 weeks instead of 16.
3 weeks from 2 days ago.
That's when the test will be?
That's when spring break is.
Oh, okay.
The test is 2 weeks from today.
Okay.
Wait, we have another test? That's
Yeah,
it.
1B.
16?
So, I noticed on the full test, you just had like one sometime, 1 year, and then like you had 1A and 1B. Did you used to do it all?
Because force and acceleration are so tied together, it just made sense early on that you do the motion and talk about velocity, acceleration, displacement, and so forth, and then force, because acceleration and force. And that way you can do a problem like this, do a force analysis, find acceleration, and then it leads nicely into the linear motion problems. Based on past classes, it seemed to be too much material all at once, and so that's when I split it into 2 tests. Now, they still count as 2 different tests, it's not half a test and half a test. But if you're looking at old tests, if you see test 1, that's when I was still combining all the material into 1. And then test 1A would be the stuff that you've already done, and 1B would be concentrated on forces.
It's back to taking a test on chapters 2
yes.
through 7.
Traditionally, there have been 4 test grades.
That's what the test
So there's
1
still 4,
was,
you make
was
it
test
five.
1, 2 through 7.
And you
Instead of
split it
2 through
into
4.
But that, there are 4 because I split that one into
Oh,
2.
okay.
There's also that multiple choice test you did the very first day, that you'll get to do that again after we've covered all the material, and that'll count as a test grade. And then then everything after chapter 7.
I thought I did okay on that first.
If you want some glimpse into the future, I'm pretty sure I posted the Rube Goldberg test that, I'm not pushing that as in, hey, your test is gonna be like that. I'm pushing that one because that covers everything. That was just basically, if I looked at your answer for the final question, if that was correct, then you got automatically, I would feel pretty sure you got everything else correct in the test.
When you say Rube Goldberg test, you mean?
The first question affects the next question, affects the next question,
Oh,
affects the next question.
that's.
So if you,
There was actually one exception, but
That's
Could
not
get
true.
lucky.
if you screw up the first time,
See, I did
it was actually incredibly easy to grade, because in my spread, I had a spreadsheet that depended on the previous answer, so, oh, they had 5 for this, so let me put a 5 in there, and suddenly it calculates everything
Yeah.
else that needs to be.
Yeah.
handy.
So that we have only one test from chapter 7 to
Chapter 8 through,
chapter 8 to the end.
yes. I assume that's a look of happiness.
More fear.
Fear, fear is correct.
Anxiety.
Anxiety is correct.
The emotion of.
All right, questions before we start into the first material for the test on April 30th?
Test 3.
April 30th.
March.
No, that's for April 30th.
Straight day.
That's the last day of class.
That's test 3.
I'm trusting it won't be snowed out or anything
Really?
like
April
that.
30th?
It'll actually be test 4 by then.
Oh, really?
Wait,
That multiple choice test, that's test 3.
Okay.
Hey, April 30th, your last day of class? Wow.
Yeah, I think May 1st is the last day of the semester.
yeah.
Is it May 3rd?
Wait.
We still
We'll
got a
figure it out
while,
when we get there.
We still got a while.
I just remember it being like May 15th.
Yeah,
I
perspective.
thought they shaved off
Actually
like,
not
I
that
thought
long.
I thought they shaved off like 1 week, not like 2.
Yeah, not 2 or 3 days.
What we just did.
If you'll notice in terms of the materials here, the test is I keep looking at the wrong one. The test is through chapter 7, but we're not having a homework quiz or master set for 7. I still recommend that you do the homework. You are responsible for the chapter 7's material, even though you're not having explicit assessment on that chapter. Do not think less of it just because you're not asked to do more for it.
That's the next master set though, right? So you don't have to do it. Is that what you just said?
Well, you don't have to turn it in, but he would definitely advise
Yeah,
you.
that's
to
what I
look at
mean,
it.
turn it in.
Correct. 7, we don't have to turn.
So that's the next one on your master set list, right?
After 6 is 7, yes.
Okay. Well, yeah, yeah, okay, I see.
We got those together.
All right, so as an introduction to the next bit, I'm going to pose a problem to you. I have two objects here, object A going to the left, object A going to the right, object B going to the left.
Is this?
Chapter 8,
This is my minimum section. Is that
Uh,
the minimum or not yet?
energy.
Energy, okay.
This book does energy first.
Okay.
They are going to collide. Now, in our specific example here, I'm gonna have them collide and then break, and then separate. So let's just say this is the point where they collide, so there's A and there's B. And then this is the point when they separate, and then A is going back this way. This is A, B, A.
Why are they smooshed? They're smooshed, and then they separate, they bounce off
All
each
right,
other.
so we've got two objects heading towards each other. They hit, they separate, and go their separate ways.
So in the diagram, are they just kind of squished in a little bit?
They're supposed to be the same size, I just can't draw the rectangle the same size.
Oh. So,
We assume that the size of the objects stay the same, as the size of the objects don't change.
Rigid bodies.
Yes.
okay.
All right. While they are touching each other, there are three quantities that are the same for both. Three measurable quantities that are the same for both. So the question is, what are the three quantities that are the same for both object A and object B while they're touching each other? And just add an element of danger.
Oof.
Nice.
The force of the, I guess, the force of box B on A and the force of A on B. They're equal.
That's not how you play hangman. You have to guess a letter.
This is the physics version where you're doing words.
Has the same mass.
But hold on. Let's address that. Why can those forces not be the same?
Well, aren't they opposite?
Yes.
Yeah.
So what is the same?
The magnitude.
Yes. All right. So the magnitude of the force that they exert on each other is the same. The shorthand notation is the force that force on A from B is equal to the negative of the force of B on A. Magnitude of the force is indeed the same. So he sold the news and walked away. All right. Two more quantities. And I will say one of these quantities, even though occasionally there's a group who gets it early on, there is one quantity that is so abundantly obvious that is usually forgotten. And then I have a really obscure clue.
Force of gravity?
Force of gravity is not necessarily going to be the same. Because
Okay.
Oh, okay, I'm dead, guys.
Oh, no.
I'm more concerned that he just has a head, you know.
I would recommend,
He's ahead of the game.
if you're talking about specific forces here, this just covers all the forces, so we don't have to,
Yeah.
Oh,
you don't need to pursue forces anymore. But the force of gravity, the reason why I went ahead and counted that one, is you made an assumption that you cannot make in this case.
Okay. That's an asset, you
So wait, we're assuming they're the same when they are touching.
The quantity for each object is the same while they're touching.
While they're touching.
When they're playing
Their
coefficient of friction.
Between the boxes.
I guess there are two sentences. I'm gonna throw that under the force thing, so. Coefficient of friction actually depends upon two objects. A is not gonna have its coefficient of friction, and B is not gonna have it. It's the combination that has a coefficient of friction. So, but,
You know it.
I do.
you saw the scaffold from a distance and decided that was not for you.
It is already claimed one.
Pardon?
It has already claimed one.
No, they are not necessarily gonna have the same speed. Because
Come on, man.
they're not necessarily going the same speed to begin with, and therefore, when they first touch, they're going that speed. They will slow down. If they bounce apart, there is a moment when the speeds are the same, when it's zero, but it's not necessarily throughout the whole time.
Does it matter what type of collision it is?
Well,
No.
this one's inelastic in this case.
Pardon?
So this one's inelastic collision, that's basically, they don't become one, bounce apart, but we're talking about only when they're touching, so it doesn't matter.
Yeah, they're not sticking together in this scenario, although the generalizations we're coming up with here should be the true, whether they stick together or not.
When they're touching, they both have the same energy.
Same energy?
Yeah.
Not necessarily.
Static friction.
Okay, that's under forces then again.
We can just lump all the forces together.
There's no more forces.
Yeah, I guess you could say something about the weight. I guess, I don't know.
Well, they're not equal, they're more combined.
Oh, yeah. Maybe. You already have to.
I already tried. I'm too scared.
If the weights are the same, what else has to be the same?
What's the mass? Yeah.
The masses are not necessarily the same. I told you no information about the mass. The masses do not have to be the same.
So, the mass
The size of the box.
Or even
I mean, not necessarily.
So we're looking for quantities that are the same.
Just drawn that way.
For each of the masses?
Yes.
I thought you meant quantities that would be the same for each respective mass before the collision and also after.
No, it's while they are touching, A has certain quantities, B has certain quantities,
Which one's it?
measurable quantities.
That means their normal force would be.
Yeah, that's
We're
force.
still lumping that under force. But that's why I gave the head for the force of gravity, because that's like saying that the mass is the same.
Their relative displacement,
What do you mean relative displacement?
like how far they are from each other.
The fact that they're touching each other?
You're stupid.
While they're touching each other, there is zero distance between the surfaces. I will agree
I
with that.
mean,
True, but that's not gonna.
Yeah, you said one of them was obvious, so.
Oh, okay.
That's why.
Yeah, that was not the obvious one I was thinking of. So I guess
Less
it's the
obvious or
ones.
more obvious?
Well,
Clearly less obvious.
What are we talking
When
about?
they're
it was not what I was thinking of, so I'm gonna go with less obvious, but I don't know. But apparently for Michael, it was more obvious. All right, let's bring it back. We have a limited number of quantities that we've covered.
So I guess within the thing, within like A or within B, when it hits, it kind of compacts.
No.
We assume rigid body.
Okay.
Acceleration?
No, because the force, the magnitude of the force is the same. In order for acceleration to be the same, the mass would have to be the same. F equals ma. So acceleration, vector or
Doing
scalar.
so good.
That's fair. You provided the cool idea.
A pushes B, so we usually have a certain direction. We always.
Armless person.
So are we talking about the moment of impact specifically?
While they're touching. for from the moment they first touch the last moment they stop touching.
Okay. Direction of motion is the
They were
same.
useless anyway.
Do they hit at the same time?
Yes, I agree with that. Let's get to what quantity are you talking about?
Do they hit at the same time?
They would have to.
Okay, I didn't know.
I've actually wondered, because when you get
When
into.
you have A moving faster than B or so forth, and one touches first, then you could get it, you know.
No, they're touching it each
Like,
other.
Yeah, there's,
We're talking on a quantum level here.
Yes.
even taking quantum physics into account, is it possible? The only way that you actually have that scenario where they don't touch at the same time, and again, touch, I'm gonna loosely define as the forces are not exerted at the same time.
Yeah.
In other words, we're violating that, is if we're dealing with, say, something like a gravitational force.
Yeah.
And if I have these two masses that are sending out what's called gravitational fields, and if this sends out the signal and then starts moving away,
Yeah.
and this is moving towards, this one's gonna get the signal from the one on my right before that one gets it from the one on the left.
Okay.
So that's a situation there where you could have a violation if you start dealing with,
Just a car crash. He crashed
Yeah,
into me
that's-
first.
Yeah. That's what I was.
but this is classical physics, you will not have that situation.
I was thinking of a car crash.
So-
He crashed into me
Is
first.
this generalized hypothetical, but we're not assuming third order equals-
We assume they are coming, it's a one-dimensional problem.
So,
Thomas?
So when they collide, they both move the same distance.
Therefore, you could go with distance, but combine that with what Russell said.
Same displacement
Stop.
after.
Same displacement.
Same displacement. They are both going, if they're rigid bodies, A is going from here to here, B is going from here to here. They have the same displacement.
Is that the obvious one?
No, that's not the obvious one.
Oh, great.
Okay, and then it's probably not the one I'm
Wait,
thinking
we were
of.
looking for 3, right?
Yeah, there's the third one's the obvious one, but here's the obscure clue. And I did have I had one student who actually knew the reference. He didn't remember the song, but he remembered the person. It's the name of a Bobby Sherman song. Bobby Sherman.
Nope.
Can you hum us your tune?
Hold on.
I will vocalize it. It's a really sad one. There's a lyric in there, "We all gotta die." That's a, it's what teens want.
Well, it's definitely not the answer I was looking for.
It's Black Parade question. What? Huh? You got a question? What is it?
But I did have a student who had seen Bobby Sherman in concert.
Displacement, so he's saying when.
Yes.
Wow.
Oh.
They touch each other for the same amount of time. Cameron was really close.
Oh.
They first made contact at the same time, they stop at the same time, the duration,
He
the
crashed into
time
me first.
that the force is exerted on A is the same amount of time that the force is exerted on B.
I don't.
So basically they shared their energy and stuff. So
They shared their what?
I mean, like the energy, like it translates or something. Like the
Uh,
force
with-
or the energy translates, so that's why they stopped at the same time and they both did the same. They have the same displacement.
I hesitate to go that far. We're about to talk about energy, so reserve that thought. Thomas?
So when they collide and they move a little bit, while they're moving, is the never mind.
You're making an argument the velocity is the same, is that what you're going for? Or did I just?
Well, I was going.
We
I was
already have
going.
velocity.
That's what I was thinking that, and I was going to ask if momentum's the same, but it's not.
Yeah, momentum is not necessarily the same, not throughout the entire journey. All right, so the reason why I go through this, and by the way, I know it takes a while to get all of them. I have asked some people, I said, all right, this is what I want, how do I ask the question? And what I got back was exactly how I'm asking the question. So I don't have any way of slimming that down. But if I combine these two things, this gets into the idea of energy and work.
Okay, which one was supposed to be obvious?
If I combine the first one and the time, this gets into the idea of momentum and impulse.
Oh, what was the name of the Bobby Sherman song?
Time. It's time, we all die sometime, no matter who you are or what you do, we all gotta go, we all gotta die sometime.
Sounds terrible.
That's a mood lifter.
Well, you know, true.
Well, one thing I will say for him, the voice you're hearing is his voice. If you ever go listen to a Bobby Sherman song, you might be going, eh, but you know, it was pre-electronic manipulation. So now let's take a look at just one of them. So the force on A from B times the displacement of A. Just gonna multiply those together. Now, I don't think we've done dot product before. We did not talk
Did, but not really.
very briefly. All right. So this is where we do dot products a little bit more hardcore.
Oh, no, not hard, not hard.
So dot product as opposed to cross products. Dot product cares about the parallel. How much of the force is in the direction of the displacement? Either parallel or anti-parallel. So if I take a dot product of A dot B, I have some vector A here, some vector B here. How much of A is in the direction of B? Take some angle theta. And so we can break A up into its components. And so this is A cosine theta. This is A sine theta. And so A dot B would be A cosine theta times B. Or so as a, I guess, refresher. So if I have 5 newtons at a 30-degree angle, dot product with 6 meters at a 45-degree angle, I basically multiply 5 newtons, the magnitude of the first one, times the magnitude of the second one, times the cosine of the angle between them, which is 15 degrees. So 30 Newton meters times whatever the cosine of 15 degrees is. Should have made something nicer.
Like 0.9, whoa, what? Yeah, well, the cosine of 15 is 0.966, and it's the, is 28.977.
If we have it in rectangular form, so we'll won't bother with units. So 5i minus 3j, dot product, negative 2i plus 7j. You can go through and FOIL